Hi everyone, my name is June and welcome to Smart Alex Mathematics. When I teach students how to solve linear inequalities, what I find is that whilst most students are able to follow through the steps in obtaining the set of solutions, what they lack sometimes is the understanding in terms of what those solutions actually mean. Another problem is that as we observe the workings, sometimes a lot of students do get confused as to when they actually have to reverse the inequality sign. So what I want to do in this video is to go through the theory behind solving linear inequalities so that you can avoid that confusion. Let's get started. The first thing we want to consider is the difference between equations and inequalities. In an equation, we have an equal sign, and in an inequality, we generally have a less than or a greater than sign. When we solve an equation, what we're looking for is a specific value of x that will make that equation true. For example, in x plus 3 is equal to 5, this equation is true when x is equal to 2. Because when x is equal to 2, our left-hand side is 2 plus 3, which is 5, and this is equal to the right-hand side. To represent the solution to the equation, this is simply going to be a dot at x is equal to 2 on this number line. When we solve the inequality x plus 3 is greater than or equal to 5, what we're now looking for is the range of values of x that will make it true. If I take x is equal to 2. The left-hand side is 2 plus 3, which is equal to 5. Well, that is still going to be greater than or equal to 5, so the inequality will still be true. If I say take x is equal to 4, my left-hand side becomes 4 plus 3, which is 7. Now, this is still greater than or equal to 5, so that's still going to make the inequality true. But let's say I now take x is equal to 1. If I take x is equal to 1, my left-hand side becomes 1 plus 3, which is 4. Now, this is no longer greater than or equal to 5, and this inequality will no longer hold. So the solution to the inequality x plus 3 is greater than or equal to 5 is going to be a range of values of anything of x is equal to 2 or greater than 2 onwards, and we represent it as an arrow on the number line. So the key idea here is that when we solve an equation, the solution is a specific value, and when we solve an inequality, we often get a range of values. When solving an equation, as long as you do the same operation to the left and the right-hand side, you can always guarantee that the equality will always hold. This is not necessarily the case for solving inequalities. What we're going to look at now are the different operations and how each one affects the direction of the inequality sign. Firstly, addition and subtraction does not reverse the inequality sign. Here I've got the statement that 10 is greater than 5, and we know that that is true. What I'm going to do is I'm going to add 2 to both sides. So when we get 10 plus 2, that gives us 12. 5 plus 2 is 7. Now 12 is greater than 7, so this statement remains true. So we see that the inequality sign doesn't reverse. Let's look at subtraction. I've got again 10 is greater than 5 as my statement. I'm going to subtract 2 from both the left and the right hand side. 10 minus 2, that's going to give us 8. 5 minus 2 is going to give us 3. And of course, 8 is greater than 3. So this statement remains true. The inequality sign does not reverse. So adding or subtracting a number to both sides of the inequality does not reverse the inequality sign. How about multiplying or dividing both sides of the inequality by a positive number? We start with 10 is greater than 5. We're going to multiply both sides by 2. 10 times 2 is going to give us 20. 5 times 2 is going to give us 10. Again, 20 is greater than 10, so this is still true. The inequality sign remains the same direction. For division, 10 is greater than 5. I'm now going to divide both sides by 2. 10 divided by 2 is 5. 5 divided by 2 is going to give us 2.5, and we still have 5 is greater than 2.5. This is true. We see that the inequality sign also does not change direction. So multiplying or dividing a positive number to both sides of the inequality does not reverse the inequality sign. How about multiplying or dividing by a negative number? We start with 10 is greater than 5. This time I'm going to multiply both sides by -2. On the left now, we're going to get -20. On the right, we're going to get -10. But is it still the case that -20 is greater than -10? No, that's not the case. So this is false. We see that, in fact, when we multiply both sides by a negative number, we actually get -10 being greater than -20. So here, the sign reverses in direction. Let's look at dividing by a negative number. 10 is greater than 5. I'm going to divide both sides by -2. 10 divided by -2 is going to give us -5. 5 divided by -2 is going to give us -2.5. This is not the case. -5 is not greater than -2.5. This statement becomes false. In fact, it is -2.5 that is greater than -5. So here the sign reverses. So multiplying or dividing a negative number to both sides of the inequality reverses the inequality sign. Another scenario where the sign also reverses is when we take the reciprocal of both sides. Here 10 is greater than 5. I'm now going to take the reciprocal of both sides. So 10 now becomes 1/10. 5 becomes 1/5. Clearly 1/10 is not greater than 1/5. In fact, the correct statement is 1/5 is greater than 1/10. So this is another scenario of where the inequality sign reverses when we take the reciprocal of both sides. So in summary, adding, subtracting by any number, positive or negative, the direction of the inequality sign remains unchanged. When you multiply or divide by a positive number, the direction of the inequality sign is also unchanged. The only time when you have to reverse the inequality sign is when you multiply or divide by a negative number or when you take the reciprocal. So we've now looked at when and why we reverse the inequality sign. In our next video, I'm going to be working through some examples to show you how to solve linear inequalities. So I'll see you all in the next one. Bye for now.